Hey guys, hopefully everybody is doing well. Miss Teresa and I are missing y'all's faces and are ready to see y'all when we get back. Currently, that's looking like sometime in May. Until then, let's kind of get started on this next lesson, which is over molarity. Um, all right, so in a previous lesson, we talked about solutions. Now, remember, solutions are basically just a type of mixture, specifically a homogeneous mixture. So, again, homogeneous or homogeneous, what that means is that they're going to look the same throughout. So, the solution is not going to have any particles that are easily seen without using some kind of special equipment. Um, for us, when we are looking at those solutions, one thing that we've kind of made a generalization of in the past is that we're always going to be talking about um, adding 100 grams of the solvent. Um, but in this lesson, we're going to focus on figuring out different concentrations of the different substances. So the word concentration does refer to how much solute is dissolved. So that's what this is talking about right here. So the word concentration refers to how much solute is actually going to be dissolved. So we're trying to figure out how strong the solution is. Do I have a lot of the solute dissolved, or do I have a very little bit of the solute dissolved? And we use these two terms here, dilute and concentrated, to help us signify that how much solute is dissolved. So dilute basically means that there's only a little bit of the solute that's actually been dissolved into the solution. Okay, it's been dissolved by the solvent. So I put very, very little of that solute in there. Okay, now an example of this would be like making Kool-Aid, and then when you made that Kool-Aid, you only put like a teaspoon into your cup versus putting a cup into your cup. Okay, so there's an issue I have with the imperial system. We talked about it earlier in the year, imperial versus metric. We use the same terms over and over and over for different things. But for this, a dilute is going to be something like a very, very weak Kool-Aid. So you didn't put a whole lot of the Kool-Aid powder into the water. So when you drink it, you're either not going to taste it at all, or it's going to be nasty because it's too diluted. The other option is concentrated. Concentrated is exactly what it sounds like. It means that you've put a very, very large amount of the solute into the solution, and a lot of it has dissolved. And so that's going to be a very strong or very concentrated solution. Okay. Now, these again, they're not numerical values. These are just generalizations that we make. I can look at a solution and say, okay, well, that's probably concentrated or that's probably dilute. Okay. But it's not a numerical value. We're not going to say exactly how much is in there. The lesson today is figuring out exactly how much is in there. So for how much is in there, we use the term molarity. Molarity is synonymous or the same as concentration. Okay, it's basically the number of moles of solute per liter of solution. Now, these are very, very important. Moles and liters are going to be very important. You will often find that I'm not going to give you a problem that's in moles and liters. I might tell you you have this many milliliters or this many grams. And you will need to make that conversion to get them into moles and into liters. Okay. So here's our formula. Molarity equals moles of solute over liters of solution. Another way I can write that, big M, that stands for molarity, equals moles of solute over liters of solution. Moles of solute over liters of solution. Another important thing is it is the liters of solution, okay? Remember, the solution is everything that's involved. So it's the solute and the solvent combined. So when we're done, the liters of solution is everything combined. It's not just the solvent. So it's not just the water, okay? So here's an example. So it says, suppose we had 1 mole of sucrose. Sucrose is about 342.3 grams. And we proceeded to mix it into some water. It would dissolve to make sugar water. We keep adding water, dissolving and stirring until all of the solid is gone. We then made sure that everything was well mixed and there was exactly 1 liter of solution when we were done. What would be the molarity of this solution? Well, the molarity would be 1.00 moles per liter. Okay, so how did I figure that out? Molarity equals moles of solute over liters of solution. So molarity, in this case, equals the moles of solute. Okay, so what was dissolving was the sucrose. And they told us that we had 1 mole of sucrose right here. Okay. And we proceeded to add water and stir and all of that until there was exactly 1 liter of solution. So when we were done, there was 1 liter of the solution. Okay, so there's our formula. 1 divided by 1 is 1. Okay, so that's how I ended up with 1.00 molarity, or 1.00 moles over liters. Okay, moles over liters would be here as well. Okay, and again, you could write it either way. Either way is acceptable, and that's what you're seeing right here. The answer is 1.00 moles per liter, or you could write it as 1.00 with a capital M at the end. Okay? All right. Now, when you're doing a calculation, please don't forget to convert that big M, this, into moles per liter. Okay, big M is just the shorthand for moles per liter. Okay, so make sure that you are converting that back into moles per liter if you are redoing a calculation. Okay, so example 2 says, what is the molarity when 0.75 moles is dissolved in 2.50 liters of solution? So again, it's moles of solute over liters of solution. I know that this 0.75 is the solute because they said it was dissolved in it. Remember, solute is the thing that is being dissolved. The solvent is what's causing that to dissolve. Okay? So I have my moles of solute and I have my liters of solution. Again, my formula, molarity is moles of solute over liters of solution. So that's what we see right here. Okay, 0.75 moles over 2.50 liters. We plug that into a calculator, we're going to end up with 0.300 moles over liters, or molarity. Okay, now, again, like I was telling you earlier, I'm not always going to give you liters or moles. A lot of times I'm going to end up giving you grams. And the reason I give you grams is because in a lab scenario, we can't measure in moles. We have to measure in grams. We have a tool to measure in grams, a balance. Okay. And so when I'm giving you something in a lab or in class, it's going to require you figure out your grams and see how many moles are in that many grams. Okay. So suppose you had 58.44 grams of sodium chloride and you dissolved it in exactly 2 liters of solution. What would be the molarity of the solution? Okay, well, first off, let's remember our formula. Molarity equals moles of solute over liters of solution. Okay, so molarity equals, well, I need to have moles first, right? They gave me grams of sodium chloride. So let's first convert that into moles. Okay, so I know that I have 58.44 grams of sodium chloride. It is not what we are looking for. I know y'all are glad to see the dimensional analysis is back again. Grams of sodium chloride into moles of sodium chloride. Okay, there is 1 mole for every, well, I need to find my molar mass. Okay, so here is y'all's periodic table. For sodium, I have 22.99. It's over here on the left, number 11 on the periodic table. And for chlorine, I have 35.45. So my mass was 22, sodium was 22.99, and chlorine was 35.45. Okay, we've got one of each of those. So we add them together and we're going to end up with 58.44. Okay, so there is 58.44 grams per 1 mole. Well, if you notice, those are the same number, so we're going to end up with 1 mole of sodium chloride. Okay, specifically, it should be 1.000 moles. Okay, remember your sig figs. Okay, so now I have my moles of solute. So my moles of solute was 1.000 moles over liters of solution. Well, they told me that I had exactly 2.00 liters of solution. So 2.00 liters of solution. Okay, so molarity equals 1 divided by 2, which is 0.5. But again, remember our sig figs, 0.500 moles per liter, or you could write it as 0.500 big M. Okay. Either one of those answers is okay. All right. So now let's move on. Number 4 says calculate the molarity of 25 grams of potassium bromide dissolved in 750 milliliters. Okay, well, 2 things I noticed right off the bat is, first off, they do not give me moles. So I'm going to have to convert that into moles. The second thing I noticed is that they did not give me liters. So I'm going to have to convert that into liters. Okay. All right. So let's start off with converting our potassium bromide into moles. So I have 25.0 grams of potassium bromide. Okay. We convert that from grams of potassium bromide into moles of potassium bromide. There's 1 mole for every. Okay, now I need to find the molar mass. So let's go back to our periodic table. So I have 39.10 for potassium, and I have 79.90 for bromine. Okay, so 39.10 for potassium and 79.90 for bromine. So potassium is this, bromine is this. We add those 2 together and we're going to end up with 119.0 grams of potassium bromide. So that's what's going to go right here, 119.0. Okay, I'm going to plug that into my calculator and I'm going to end up with 0.210 moles of potassium bromide. Okay. Now remember our formula for solving molarity is molarity equals moles of solute over liters of solution. Okay, so moles of solute is 0.210 moles. But I need liters of solution. Okay, well, right now they've given me milliliters. So we're going to use our saying, King Henry died by drinking chocolate milk. Okay, so that we're going from milliliters to liters. So we're going from milli into the base. So that's 1, 2, 3 times to the left. So I'm going to take my decimal and I'm going to go 1, 2, 3 times to the left. Okay, so that gives me 0.7500 liters of solution. Okay, so 0.210 divided by 0.7500 liters, and that's going to give you your molarity. So my molarity ends up being 0.280 moles per liter, or 0.280 big M. All right. Example 5. We have 80 grams of glucose. Glucose is C6H12O6, and they already tell you that its molecular weight is 180 grams per mole. So you're not going to actually have to solve for that one. It is dissolved in enough water to make 1 liter of solution. So what is the molarity? First thing that I'm going to need to do is convert from our grams that they gave us right here, into moles so that we can plug it into our formula. So I have 80.0 grams of glucose, C6H12O6, and I'm going to convert from grams of that into moles of that. There's 1 mole for every 180 grams. Okay, we plug that into our calculator, we're going to end up with 0.444 moles of glucose. Okay. Now we've got our formula. Remember, our formula is molarity equals moles of solute over liters of solution. So molarity equals 0.444 moles over liters of solution. Well, they told us that we had 1 liter of the solution. So 0.444 over 1.00 liters of solution. So then my molarity equals 0.444. And again, you could just write moles per liter or big M. Okay. So that's solving for molarity. Okay. Well, the other thing is actually applying that into a chemistry class. And so applying that means making solutions or making things with the right concentration. Okay. So for making solutions, we need to use a volumetric flask. Okay. A volumetric flask, its purpose is to actually create solutions. It measures an exact volume. Okay. Now, I'm going to show y'all a video, and I'm going to talk you through it. So first, after you have solved for molarity, then you're going to have a mass. Okay? You might actually have to convert it back in the other direction and figure out what mass you need of the substance to add. So in this case, we're going to measure out to 5.84. Whatever the solution was, they decided to measure out to 5.84. Okay? So they take that. Once they've got their 5.84 grams, and it looks like it's 5.83, they're going to add that to their volumetric flask. Now, the size of the volumetric flask is very important. It depends on how much solution you're trying to make. If you're trying to make 1 liter of solution, you would use a 1 liter volumetric flask. If you're trying to make 500 milliliters, you would use a 500 milliliter volumetric flask. In this case, they're using a 100. So I've got a 100 milliliter volumetric flask. I'm going to add the solute into that volumetric flask. Okay. Now, a lot of times what you'll notice is that some of the powder actually gets stuck to the inside of the whey boat. So you need to rinse it off. Okay. And we typically use distilled water for this. Okay. Distilled or filtered water, because that removes all of the extra contaminants that are in something like tap water. Okay. After you've done that, you're going to pour it into, make sure it's in your funnel, and that'll drop down into your volumetric flask. And then you're going to keep adding water until the volumetric flask is about half full, okay? That gives it a way for the solute to dissolve, okay? And then you're going to start to swirl it, okay? You're going to mix it up, okay? Now, you don't stick something down inside of it because that's going to get some of that solute and the solvent actually stuck to whatever you're trying to mix it with. So we don't use that. We instead swirl it, just like you saw in that video right there. Once you've swirled it, you're going to keep adding water. Now, on all volumetric flasks, there is a line on the stem. That line represents the amount that you want to end up at. That represents whatever the size of your volumetric flask is. In this case, it's 100 milliliters. So once you get close, you'll slowly add water up to that line. Once you get to that line, you'll cap it off. You'll mix it one more time, and then you're done making your solution. Okay, so here's an example they give. If 2 moles of potassium nitrate were dissolved in enough water to make 1 liter of solution, okay, now again it says, notice that it doesn't say 1 liter of water, because when you mix these, you're not necessarily going to need to add 1 liter of water, because remember, there is another substance there. Okay, so when my solution is done, it needs to be 1 liter. Okay, the concentration of the solution is said to be 2 molar, or simply 2.0 m. So how would I make this? First off, I would need to calculate how many grams is in 2 moles of potassium nitrate. Okay, so we would work through the problem, we'd solve it using our molarity equation, and we'd figure out how much mass is involved. After that, we weigh out that mass, and then we're going to put it onto using a balance and a weighing tray. And once we've got that mass weighed out, we're going to use a funnel of some variety. You can use a paper funnel. You could use one of the plastic funnels we have in class. The type of funnel isn't necessarily important. The important thing is that you get it all into the volumetric flask. So you're going to need to rinse out your weigh boat, and you're going to need to rinse out your funnel. Okay. After you've done that, you're going to fill your flask about 2/3 full of water. Half to 2/3 is good typically. Then you're going to swirl that flask. Okay. You want to make sure that all of that potassium nitrate in this case is dissolved. Okay. Once it's all dissolved, then you're going to bring that solution level exactly up to the line, okay? Again, it should be the bottom of your meniscus should be where that line is, okay? Okay, so example 6 says, how many grams of sodium hydroxide must be used to make 500 milliliters of a 2.5 molar sodium hydroxide solution? Okay, well, first off, again, we're working with concentration. This needs to be in liters. Okay, so I need to convert that into liters. King Henry died by drinking chocolate milk. We're going from milla into the base, 1, 2, 3 times to the left. So we'll take that decimal, 1, 2, 3 times to the left. So I have 0.500 liters. Okay. Well, remember our molarity formula is molarity equals moles of solute over liters of solution. In this case, we're going to need to solve for moles, okay? So I'm going to have to rearrange this equation, okay? So I need to get moles by itself, so I multiply both sides by liters to make sure my moles is on the side by itself. So moles equal liters times molarity. Okay, now I can plug in my numbers. So my moles equal, my molarity was 2.5, and my liters, my volume, was 0.500. So 0.500 times 2.5. Okay. This is liters, and this is moles per liter. Okay, we got liter on top and liter on bottom, so they cancel out. You're going to be left with moles. All right, now that is what makes it important, why it's important for you to actually take that big M and convert it back into moles per liter. All right, so we're going to multiply those together, and we are going to end up with 1.25 moles of sodium hydroxide. Okay. But my question is asking for my mass. How many grams? So we're going to take that and we're going to convert from moles of sodium hydroxide into grams of sodium hydroxide. 1 mole is equal to, well, I need to find my molar mass. Sodium has a mass of 22.99. Oxygen has a mass of 16.00. And hydrogen has a mass of 1.01. Okay, we're going to add all of that up, and you're going to find that it is equal to 40. Okay, so we'll take our dimensional analysis, 1.25 times 40, and y'all will end up with 50 grams of sodium hydroxide. Okay, so if we were making this 2.5 molar sodium hydroxide solution using half a liter or 500 milliliters, we would need 50 grams of sodium hydroxide to do that. Okay, so how would we prepare it? When we prepare this, okay, well, we've already solved for how much we need, so we don't even need to put that there. Okay, what we do need to do is we need to weigh out 50 grams of sodium hydroxide using a balance and weigh boat. Okay, next, using a funnel, pour all 50 grams of solute, well, which is sodium hydroxide, into now here's where it's important that you know your volume of your volumetric flask. I need to make make 500 milliliters. Okay, so I'm going to use a 500 milliliter volumetric flask into a 500 milliliter volumetric flask. Okay. Step 3. Fill the flask two-thirds to a half, 2/3 full of water. And again, this needs to be either filtered or distilled water. Okay. Step 4, swirl the flask. And again, it's not stir, because stir implies that you're putting something into that solution. So swirl the flask until all the sodium hydroxide has dissolved. Okay. And then step 5 would be to carefully add water. Again, that needs to be filtered or distilled. Until the flask has been filled to the line. Okay, so those would be the steps for preparing a solution. Okay. Now, if you'll notice, the phrase of solution does keep showing up. Okay. Remember, molarity is a definition based off of the volume of the solution, not the volume of how much solvent you're adding in there. Okay. So keep that in mind. The reason it's important for us to look at the volume of the solution is that volumes aren't actually additive. Okay. So when I take 1 liter of water and I mix it with 1 liter of alcohol, rubbing alcohol, they don't necessarily end up being 2 liters. A lot of times it's like 1.98 liters of that solution. Okay. Because volumes don't actually add up. They are not cumulative. They are not additive. Okay. It's just a unique thing about chemistry. Basically, those molecules can actually slide in between one another. Okay. All right, that is it. Hopefully, y'all understand molarity now. If you do not, though, that is okay. We will end up having a tutorial session later, so please keep an eye out for when that is, and we will help you when we can. All right.